Hello everyone, today I'm going to be showing you how to make a single player FPS game in Unity. This game will consist of a player who has multiple different guns having to face off against enemies that get more and more progressively difficult as time goes on. Throughout this whole series you will learn a lot about Unity as well as object-oriented programming. This tutorial series will assume you have basic knowledge of C# and Unity, so we won't be going over any basics. With that being said, let's get started. First, let's rename our scene from sample scene to game scene so we know what scene we are talking about. Next, what we'll do is we'll create a simple plane that our player will move on. And then let's scale it up a bit just so it's nice and large. And then let's reset our transform so it's at the center so it's easier to work with. Next, let's create our player object. Well, actually, we're going to create a capsule for our player, and we're going to move. So let's reset his transform as well. Let's move him up a bit, and then let's add a character controller component on him. Remove the capsule collider as it's not necessary since we're using a character controller. Finally, let's move our main camera and make him a child of the player and reset the transform of it, and then move him up. This will give a first person feel for when we're moving around. Next, let's create a scripts folder, and we're gonna start off with our player movement scripts. Let's create a script called player movement. Next, let's attach the movement script onto the player. And then we're going to open it up. Now for a player controller, we're going to need three variables for it. Speed, to handle how fast our player will move when we press down. For gravity, for how fast the player will fall down when he jumps, and the jump height, and which is the height that the player will jump when you hit spacebar. So let's add those variables now. And we will set the default speed to be 5, and we will make it a serialized field so it can be changed. And then we'll do the same with gravity, except we'll set it at 9.81, and make sure, very important, it must be negative. And we'll serialize the field for that as well in case we want to change it. And then next, here's our jump height, how high our player will jump, and we can serialize that as well. Next, we want a vector 3 for our player velocity. Now this is for storing the y velocity of the player. When the player jumps, we need to set its initial y velocity to the jump height. Then every frame we want to apply gravity by adding the gravity variable we just created to the y velocity. Since gravity is negative, it'll eventually cause the player's velocity to become negative, or y velocity rather, and then we'll just have a check for if the player is touching the ground, and then we'll then set the y velocity to 0. And so that's why we have this velocity vector, and the reason it's a vector 3 is so we can use our character controller to move it. And speaking of that, we need to get a reference to that. So let's get a reference to the character controller by creating a variable for it, and then we'll just call getComponent in the start method. And then first, what we're going to do is we're going to check if the player is grounded. And then we can just do that by calling controller.isGrounded. And then we're gonna change this velocity vector really in just a minute, but we're gonna first check if the player is grounded and the velocity vector is less than 0. If it is, then we have to set it to 0 so the player won't continuously keep falling down. So let's do that now. and make sure it's the y. It's only the y component. So we'll set it to 0. So next, what we need to do is we have to get our keyboard inputs, and that's quite simple. We can just use input. We can use our input methods, and then we're gonna create a vector 3 to store our movement. And then we just use input.getAxis and then the x is gonna be horizontal, and then the y is gonna be 0 because we're using this vector 3 over here to handle the y velocity, and then z is gonna be our vertical input, or vertical axis rather. And then we just call controller.move, and then we pass in this move, we multiply it by delta time, and then we have to multiply it by our speed. Next, we have to check if the player is jumping. So what we can do, we can call input.getAxis, or not getAxis, rather, get button down, and it's going to be the jump, which is just spacebar by default. Excuse me. And then we're also going to want to check if the player is grounded. And then if it is, we'll set the player velocity to equal to our jump height, and jump height is 5, and that's positive. So then what we're gonna do is we're gonna add to our y velocity our gravity variable and multiply that by delta time. And since the gravity is negative, when we set our player velocity.y to a positive value, eventually our player velocity is going to be negative as we fall, and then this line of code will execute when we're grounded. And finally, we have to just call controller.move to handle moving our velocity vector, and then we're going to multiply it by delta time. Now recompile and go back into Unity. Now let it recompile, and then wait for it to recompile, and then hit the play button. As you can see, now you can move around with WASD. And then if you hit the spacebar, you can even jump. Now, the reason why the jumping is a little bit delayed is due to the character controller.isGrounded function. It's a little bit slow. And a better way to check for grounding would be to have a collider on the bottom of the player and use that, and have a variable that resets when it collides with the ground. But for the sake of simplicity, right now I won't do that. So now, with that being said, now let's start working on player rotation. So create a new script and let's call it player look. And now let's open that script. So first, for our player look, let's add a variable for our sensitivity. This will just it's pretty self-explanatory. And then let's add a float for our x, our limit on the x. This will limit how much we can move in the x direction, or rather rotate. And then let's add a transform reference for a pivot point, since we can't directly just rotate the camera. So we have to rotate a pivot that holds the camera. And then finally, we'll store our current rotation, our x and y rotation. And then let's set them to 0 at first. and let's put F there just. And then in our start function, let's set our cursor and let's set the lock state to be locked, so just so it doesn't move around. And then we don't want to even see our cursor when looking around, so and then we'll just make it invisible by setting the cursor.visible property to false. And then in our update function, let's start with adding a rotation X. Let's add it to our input, so that should be negative. So we'll say rotation X is equal to the current value plus input.getAxis our mouse Y, and then we're gonna multiply that by our look speed, or rather sensitivity, my bad. And then we're gonna say rotation X, and we're gonna clamp it now. And then we're gonna do that by setting clamp. We're gonna clamp our current value. We're gonna clamp it with the X limit, with our negative X limit, since it can rotate in a positive or negative direction. And then so the minimum, the rotation range is going to be from this value, which is going to be from a negative value to a positive value. So for instance, if this was the excuse me, if the rotation X limit was like 90, it'd be from negative 90 to 90. Anyway, so next we have rotation Y, and we'll use input.getAxis, and we'll use our mouse X. We'll get the mouse X, and then we'll just multiply that by look speed, which is our sensitivity. And then this is all again, but this isn't really doing anything. We actually have to update our camera with this, or rather our pivot. So let's create a function to do that. So let's say public void update camera, and then what we will do is we'll set our pivot's local rotation equal to the Euler angles of our rotation X, and then we'll set our Y and Z to 0, and then we'll set our rotation, the transform rotation, and that will be multiplied by quaternion.Euler and then our rotation Y. So this is updating our X rotation, and this is handling our Y rotation. And then we just have to call this every time we finish updating these values. Now let's go back into Unity and let's create our value. Let's create our pivot point. So I'll call this pivot. And then this is very important. The main camera must be a child of the pivot. And then we can add our player look. And then let's set our sensitivity to 1, and then our X limit we'll just do 90. And then we'll set our pivot to be this pivot transform we've just defined. And now if we run it, we should be able to look around and move, but there seems to be a problem. When we rotate our camera, we move in the direction, we still move in the forward direction even if we're facing a different way. And so why is this happening? Well, if we go to our player movement script, we have to make a quick change. We have to multiply this. Well, instead of doing this, instead of creating a new vector 3 just with our horizontal and X and vertical, what we're gonna do is we're gonna say our vector 3 move is going to be the transform.right direction, and then we're going to multiply that by input.get axis horizontal plus transform.forward times our input.get axis vertical. Basically, this will give transform.right will give us our direction in world space. So when we move, when we rotate our camera, it'll actually update. And now if we test it, it seems to be working. So now that's it for this tutorial. Our player movement's working. We can jump, and yeah. So I'll see you guys in the next tutorial.